Why don't I see the world upside down? Imagine waking up one morning and opening your eyes to a world that feels crazy. You reach for something, but your hands seem to move in the opposite direction. Walking feels strange, as if gravity has shifted and everything around you looks upside down. It is as if you've stepped into a world where the rules you know no longer apply. Now, this might sound like a fantasy, but it's not just the stuff of stories. In Through the Looking Glass, Lewis Carroll's famous tale, Alice steps through a mirror into a reverse world, where everything looks familiar but behaves differently. And here's the fascinating part. This isn't just fiction. There is a hidden truth behind what happens in our eyes and the brain every time we see. This visual puzzle fascinated Leonardo da Vinci. In the 16th century, he studied how light enters the eye and forms an upside-down image on the retina. But without the knowledge of modern neuroscience, he could only wonder, how does the brain manage to flip this image the right way? A century later, René Descartes took the question further. He experimented with animal eyes and proved that the image on the retina is indeed inverted. But like Da Vinci, he couldn't explain how the brain transforms this flipped image into a coherent view of the world. But how the brain corrects the inverted image? Well, there are five main steps at this process. In the first one, when light enters the eye, it passes through the cornea and lens, which focuses the light onto the retina at the back of the eye. Due to the curvature of the lens, this image is inverted, flipped both upside down and left to right. If we could directly view the raw image formed on the retina, the world would appear upside down. In the next step, once the light hits the retina, it is detected by special light cells, rods and cones. These photoreceptors convert light into electrical signals. The rods are sensitive to light intensity, while the cones detect color. This process is called sensory transduction, where light is converted into electrical impulse. But what's happened at the third step? These electrical signals travel from the retina through the optic nerve to the brain's visual cortex, located in the occipital lobe at the back of the head. Along the way, they pass through the lateral geniculate nucleus, or LGN, in the thalamus, a relay station for sensory signals. In the next step, when the signals reach the visual cortex, the brain begins processing the image. The cortex has a retinotopic map, a spatial arrangement that matches the locations of the stimuli on the retina. At this point, the image is still upside down. But step 5 is where the magic happens. The brain doesn't just display the raw retinal image like a camera. It actively reconstructs the image to create a coherent right side up view. Several processes are involved. At the first one, spatial integration, the brain integrates input from both eyes to form a unified view of the world. This occurs in the parietal cortex and helps with depth perception. In the next step, which has the answer to our question, there are four important sub-steps. First one, interpretation based on experience. When your brain receives the inverted image from the retina, it doesn't just display it as is. Instead, it compares the incoming signals with the stored memories of how objects typically appear. Since your brain has learned that the world is upright, it reconstructs the image accordingly. Your brain has expectations about what the world should look like based on lifelong exposure to upright surroundings. This expectation drives the correction process, ensuring that even if the raw image is flipped, you perceive it as right side up. Top-down processing also helps in context recognition. For example, even if you saw a familiar scene like a room upside down, your brain would work overtime to reorient the image because it knows how that room should look like. And if your brain is exposed to an altered visual environment for an extended period, such as with inversion glasses for days, Top-down processing, aided by neuroplasticity, allows the brain to gradually adapt and form new expectations, ultimately making the altered perception feel normal. But what if one day our brain forgot to do its upside-downing job? Now imagine waking up one morning and your brain forgets its job of flipping the world right side up. The image on your retina is still inverted, but your brain doesn't correct it. You see everything upside down, and no matter how hard you try, the world would just feel reversed. Well, this idea isn't as far-fetched it might sound. In fact, George Stratton, a psychologist in the 19th century, explored this very concept. Stratton wore special glasses that flipped his visual field. At first, he felt completely disoriented. Tasks like reaching for objects and walking became difficult. But after a few days, something incredible happened. His brain adapted. Stratton's visual system relearned how to interpret the upside down world, and soon he was able to move around as if everything was right side up again. Stratton's work showed us the brain's remarkable neuroplasticity, its ability to reorganize itself and adapt to new sensory input. His experiment demonstrated that the brain could reprogram itself to make sense of an inverted world. After George Stratton, other scientists also repeated similar experiments in different ways. For example, Kohler used prism glasses that horizontally shifted the participants' visual fields. Like Stratton, he found that after sufficient exposure to the altered environment, participants showed improvement in their motor coordination, indicating that their brain had adapted to the new perception. All of these experiments, along with modern neuroscience, helps us to understand that the brain isn't just a passive recorder of visual information. It actively processes and adapts to what it sees using complex networks across the brain. The brain's ability to adjust and adapt to changes in sensory input highlights the incredible plasticity of the human brain, our ability to learn new ways of seeing, even when the world is turned upside down. But here's where things get really enigmatic. If our brain can adapt so well, how can we be sure that what we are seeing is the world as it truly is? What if everything we perceive, up, down, left, or right, is just an interpretation? We've grown so accustomed to that it feels unquestionably real. Could it be that we are already seeing an upside down or distorted world, but because our brain has fully adapted, it appears perfectly normal? This isn't just a philosophical thought, it's a profound challenge to how we define reality. How much of what we know is true perception, and how much is our brain's clever illusion shaped by years of experience and adaptation? Perhaps, in the end, what we call reality is nothing more than the version our brain has trained us to accept. Thank you for watching this video.